In lesson 12.9, we're doing inverse trig. So in the past, we were usually given an angle, and then we used that to find the value of the trig function. So now we're going to go the other way around. We're going to be given the trig function, and we're going to use that to find the angle. All right, and then an important thing is if you are given capital letters with the trig functions, that means there is a restricted domain. So let me explain what that means. So let's say we have a unit circle. So if I asked you, where does cosine equal rad 2 over 2? So you would say right here, but that's not the only spot. Cosine also equals rad 2 over 2 right here. Okay, and then those aren't the only two spots as well. This is 45 degrees. This is 315 degrees. But again, those aren't the only two spots because we could keep adding 360 to both of those numbers. So there's infinitely many places where cosine equals rad 2 over 2. Okay, so when you have capital letters, what that means is for cosine, they only want answers that are in quadrant 1 or 2. For cosine, if they use a capital letter, they only want the answer or answers that are in quadrants 1 and 2. Okay, now what about for sine and tangent? If we have a unit circle, sine and tangent, they only want answers that are in quadrant 1 or quadrant 4, as you can see right here, between negative 90 and positive 90. So this is sine and tangent. Alright, so keep that in mind as you're doing these. Okay, for number 1, where does cosine equal rad 3 over 2? Let's draw a quick unit circle. Cosine is the x, so that would be the long distance, which is here. And remember, for cosine, they only want answers in quadrant 1 and 2. So even though there's another spot down here, they don't want that. So what is this angle here? This is 30 degrees. Alright, what is 30 degrees in radians? Well, remember, pi is 180. Pi is 180. So what did pi get divided by? 180 divided by 6. So these are our two answers. Okay, for number 2, where does sine equal negative rad 3 over 2? So sine is the y. So sine equals negative rad 3 over 2 here and here. But remember the restricted domain? So we only want answers in quadrant 1 or quadrant 4. So what's that angle in quadrant 4? Well, from 270 it looks like we only went 30 degrees, so that would be 300 degrees. But even though 300 degrees is in quadrant 4, which is what we want, if you look at the domain and range restrictions, we want to be between negative 90 and 90 degrees. So 300 degrees is equivalent to negative 60 degrees, and it falls in the range of negative 90 to positive 90. And now we just convert that to radians, which is negative pi over 3. Number 3 is a little tough because you have to figure out what x and y values would lead to a ratio of radical 3. So remember that tangent is y divided by x. So seeing the rad 3, it's pretty obvious that it's either going to be rad 3 over 2 divided by 1/2, or the other way around, 1/2 divided by rad 3 over 2. So let's try both of those. If I do rad 3 over 2 divided by 1/2, so I multiply, that will equal rad 3. So tangent being y divided by x, I know the coordinates are 1/2, comma, rad 3 over 2. So where, at what angle does this occur? Well, if I draw a unit circle, 1/2, comma, rad 3 over 2 is here. Now, this would also happen when both these coordinates are negative, which would be down here. But again, tangent has a domain that is quadrants 1 and 4. So the only answer we want is this one up here, which is 60 degrees. Alright, what is 60 degrees in radians? Well, pi is 180. So how do we turn 180 into 60? We divide it by 3. Alright, going back to cosine. Where is cosine equal to negative 1/2? Cosine is negative 1/2. Cosine is the x, so that would be here and here. We have a capital letter on the arc. So they only want this answer. So that would be a little bit past 90. So 90 plus 30 is 120. Alright, 120 over 180. That's 2/3. So this is 2/3 pi. Alright, so remember that arc and exponent -1 mean the same thing. So this is the same thing as cosine, and with a capital C, cosine to the power -1. Both of these mean inverse cosine. So arc and inverse mean the same thing. Okay, now let's find another inverse cosine. We want the inverse cosine of negative rad 2 over 2. Cosine is the x, so it would be negative rad 2 over 2 in the middle here, and in the middle here. The domain restricts us to quadrants 1 and 2 for cosine, so that would be 135 degrees. Okay, 135 divided by 180, that's 3/4. So this is 3/4 pi. Alright, when would tangent equal -1? At what angle? So when could the x and y coordinates be opposites of each other? Since tangent is y divided by x, if you want y divided by x to equal -1, that means they have to be opposites. So that would either be at rad 2 over 2, comma, negative rad 2 over 2, or vice versa, negative rad 2 over 2, comma, positive rad 2 over 2. So on a unit circle, where do those occur? We know they occur in the middle, so that would be here, because x is negative and y is positive, or here. This is where x is positive and y is negative. Our domain restricts us. Our domain restricts us here for tangent. So the angle there would be 315 degrees. But again, we want our answer between -90 and positive 90. So the coterminal angle there would be negative 45 degrees. And in radians, that would be negative pi over 4. On the back side, we're doing inverse trig combined with regular trig. So we know that sine's restriction, we're going to start in the middle, sine's restriction is quadrant 1 or quadrant 4. So where is sine negative rad 2 over 2? Happens here. It also happens in quadrant 3, but we don't want that. And so this is telling us that angle. So the part I circled, that equals 315 degrees. Now they want us to find the cosine at that spot. The cosine at that spot is positive rad 2 over 2. So that's our answer. Alright, what do you do if the value they give you is not anything you ever see on the unit circle? So a ratio of 5 over 7, we don't have any coordinates on the unit circle that we know where the ratio of y divided by x is equal to negative 5 over 7. So what I would do is draw a triangle. So first, let's figure out what quadrant we're in. So cosine means you're in quadrant 1 or quadrant 2. Now, because cosine is negative, we know we want to be in quadrant 2. So how do we draw a triangle in quadrant 2? So if you recall the bow tie rule, in quadrant 2, you draw the triangle like this. Alright, so I have this quadrant 2 angle. I'm going to put theta near the origin, like we did earlier in the chapter. And I know that cosine, or arc cosine, is negative 5/7. Cosine being adjacent over hypotenuse, I'm going to put a negative 5 on the adjacent side, a 7 on the hypotenuse. And now doing the Pythagorean Theorem, 7 squared is 49, negative 5 squared is 25. So what would this other side have to be? This would have to be radical 24. So that's 2 rad 6. So I did that pretty quickly. You should know how to do the Pythagorean Theorem. So you get 2 rad 6 is the opposite side. Alright, so the answer to this question, that is the angle here. We don't need to find that angle because we're just going to find the cotangent of that angle anyways. So this part is theta, and now we just have to find the cotangent of that angle. Alright, so cotangent is adjacent over opposite. So adjacent is negative 5. Opposite is 2 rad 6, and now let's just rationalize that. If I multiply the top by rad 6, I get negative 5 rad 6, and if I multiply the bottom by rad 6, I get 12. For number 9, remember, tangent means quadrant 1 or quadrant 4. So because tangent is negative, we know we want to be in quadrant 4. So quadrant 4 triangle looks like that. Theta goes here. Alright, so tangent is opposite over adjacent. So on the opposite side, I want to put a negative 5. On the adjacent side, I want to put a 12. And that's a Pythagorean triple, 5, 12, 13. And now we want the cosecant of angle theta. So So the cosecant of angle theta, sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. And let's get the negative out of the denominator. So again, the answer to this part is just theta. Since we're not using a calculator, we're not going to find theta. We're just going to find the cosecant from theta's perspective. Alright, number 10. Cosine is in quadrant 1 or 2. Because it's negative, we know we want to be in quadrant 2. So I draw the triangle. Quadrant 2 triangles look like this. Theta goes here. Alright, so the ratio is negative 0.7. So on the adjacent side, I could put a negative 7. And on the hypotenuse, I could put a 10. Because negative 7 divided by 10 is negative 0.7. Alright, doing the Pythagorean Theorem, 100 minus 49 is 51. So this side's going to be radical 51. That doesn't break down. 3 times 17. There are no pairs in 3 times 17. Okay, so now from theta, we want to find tangent. So what's opposite over adjacent? That would be radical 51 over negative 7, or negative rad 51 over 7. And now for the rest of the notes, you can use a calculator. Alright, so to find the angle where sine equals 0.8, you're going to type second sine and then 0.8. So on your calculator, you're going to type the button second, then hit sine, and you should see this, and then put a 0.8 inside. If you do this, you get 53.1 degrees. That answer is acceptable because we're in quadrant 1. Okay, for number 12, you're going to do inverse tangent. So theta equals inverse tangent of 4.5. This gives you 77.5 degrees. Okay, well, cosecant is the reciprocal of sine. So what I'm going to do for this problem is change it, since I don't have a cosecant button on my calculator. If cosecant theta equals 2, then sine theta has to equal the reciprocal of 2. And now just do inverse sine of 1/2. So type second sine, and then put 1/2 in parentheses, and you get, you actually don't need a calculator. You should know that at 30 degrees, sine equals 1/2. Okay, and then secant is the reciprocal of cosine. So if secant theta equals negative 3.12, cosine equals the reciprocal of that, which I'm just going to call 1 over 3.12. So now do inverse cosine, and in the parentheses put negative 1 divided by 3.12, and you get that cosine is 108.7 degrees, and cosine needs to be in quadrant 1 or 2 when you have the capital letter, and this is in quadrant 2, which is good. Okay, for the last problem we have a ski ramp, which is shaped like a triangle. So here's our ramp. We know it's 5.5 feet tall, and the ramp is 12 feet long. So you might be wondering, how come I didn't put the 12 on the bottom? Well, when you're walking on a ramp, you're walking on this part. Think about a ramp maybe at the post office. A ramp is the hill, the slope that takes you up a little bit. So there's the ramp. The bottom is not the ramp. The bottom part, which is flat, well, if we wanted to walk flat, we wouldn't build a ramp. Alright, so we want a trig function to find the angle the ramp makes with the water. So that would be the angle in the bottom left of that triangle. Okay, so we have the hypotenuse labeled and the opposite labeled, so we're going to use sine. Sine of our angle equals opposite over hypotenuse. So this is the answer to the first question. Write a trig function that can be used to find the angle. And now actually find the angle rounded to the nearest tenth. So whenever you're solving for angles, you use inverse trig. So do inverse sine. So that's on your calculator, second sine, and then put 5.5 divided by 12 in the parentheses, and you get 27.3 degrees. Alright, that's all for 12.9.